Hi everyone, welcome to this session on Stay Critical About Your Data. In yesterday's session, we saw how we should validate our model at each stage using available data. Today, we will try to be critical about the data that is available to us. Often, we accept day-to-day data without question. For instance, I always believed that flossing was beneficial based on general consensus. However, an article in BBC challenged this belief by revealing that the supporting data was of low quality and potentially biased. So, is flossing truly beneficial? As one of the articles in Harvard Health suggests, absence of proof is not proof of absence. The revelation that I had from the BBC article does not conclusively prove flossing is unhelpful, but it does illustrate why we should not accept data at face value. Let's explore how accepting data without scrutiny can lead to costly mistakes in data-reliant industries like technology and real estate. The Unity software is a platform where users can create interactive and real-time 3D content. Unity ingested bad data from a large customer into its machine learning model. This machine learning model was used to place ads and allowed users to monetize their games. However, due to the wrongly trained models, the users were targeting the inappropriate audience and it led to underperforming ad placements. The company's management estimated the impact on the business at approximately 100 million US dollars in 2022. Zillow is a tech real estate marketplace. It was more advanced in leveraging machine learning than most companies. They used their machine learning models to develop predictive models to estimate home value, which had a huge impact on their business activity. They started by using the models to help their marketplace users know if they are getting a good deal. Their machine learning algorithm were however trained with pre-COVID data. During COVID, their models overestimated the value of the homes. The algorithms continued to assume that the market was still hot and overestimated home prices. The overestimation led the company to reduce the estimated value of the houses by more than 500 million US dollars. Finally, for Gemini AI, the trained data was corrected to make it politically correct. That eventually led to an output which tries so hard to be politically correct that it ends up being absurd. In today's session, we will try to validate data using models. We will try to understand the causes that create a certain trend in the data. We will use vote count data as our example, which can often show surprising trends during live events like elections or contests. Have you ever noticed a sudden shift in voting trends and wondered what caused it? By modeling this process, we will explore how modeling can help us understand and even anticipate such shifts. Let's start the modeling process step by step. So with that, I think I gave a very broad overview
Right,
about data, but not specifically mentioning how data is relevant for modeling. Like
right,
how should we
I guess,
ensure, right?
right. I guess the data itself, it's quite a broad definition, right? So when you
Yes,
mention data, what you mean
yes.
is that the data we measure or or I don't know, observe or maybe give as input? Okay, you have
So
already answered.
yeah, I already thought I already thought about that question. So the thing is, when we talk about modeling, I could think of uh, three major uh, usages of data when we refer data and a model, right? First is let's say you have a sensor data, right? and that sensor data, perhaps you want to feed it to your model for some control algorithm or for something else, right? So this is one type of
Right.
measurement data that we talk about. And when we say stay critical about it, we want to say, like, one should know what units the data were measured in. Sometimes it's in Kelvin, sometimes it's in Fahrenheit. One is to know about it. Plus, one has to be aware of the initial offset, right? So when you use sensors, you have to actually calibrate it first, then take the measurements. But sometimes if you don't do it, then you might get an offset, right? So one has to be critical about those things when you talk about measurement data or data from sensors, which can be used as an input to your model, right?
Right.
That is
Right.
one. The second is in our model, we used the parameter values, right? That is a data in itself, so system data, right? And then, for instance, if you remember in our coffee cooling process, we used data for our material of the cup, right? and
Right.
and and I just took a value for ceramic and then I used it in my model, uh, but
Or
I
thermal
had
conduction, right?
yes, so that so in the coffee cooling process, that was basically to say how the conductivity of the cup material, right? So that value, I just took it from the web or took it from the literature. But it might be the case that my coffee cup has a different combination. It's an alloy of something, right? So I have to do some test uh, and then find the parameter value. So the parameter values or system data values, those are kind of data as well, right? And the third type of data is when we do a model, we actually have a system behavior data, right? We actually know a system, we have a dynamics of the system, and we use a model to understand the dynamics, right? And then sometimes when we have the system data, we create a model to understand it. We try to understand it, and if you don't understand it, then we have to question it, that this is the data of the system that I'm getting. I'm not able to understand, or I'm not able to replicate it. What's wrong, right?
Right. So when you refer this election process, the voting
Mm.
process, then that is the output data, which
Yes. So that
okay,
is in the third silo that I just mentioned, right? We already have a behavior that we observe, and then we try to model it and use simple logic to try to understand that data, right? And that is what we will be trying to use today,
okay, okay. Yeah, thank you, Ankit.
right? Um, so the model that we are trying to uh, so uh, let me introduce the problem first. What do I mean by vote counting data? Let's consider a country X, right? And they recently had an election, and today is the election results day, which goes on for like 30-40 hours. You're constantly hooked to the television. You want to see which party won or how is the thing
Okay.
progressing, right? And then here you can see a chart here, right? You have one party. So here the election result starts,
So
let's say,
which
after 10
country,
hours
which country this data belongs to now?
This belongs to country X, and which is a
Okay, okay,
fictitious country that I came up with. So here, let's say you're tuned to the TV, and you could see that one part you have tuned at 0 hours, but for some technical glitch, the the counting starts after, let's say, 10 hours, and then you start looking at the trends, or the actual not the trends but the actual values, and you see one party is leading, and the one party is lagging, right? And suddenly after a few hours, you see a
So
sudden
what is that y-axis?
the y-axis is the percentage of votes. So as we start, the first party is getting 51% of vote, and the second party is getting 49% of the vote, so they're pretty close to each other.
Okay, yeah.
And then what happened, while you're watching it, suddenly you could see a sudden change in the result, and then and then once you reach a peak, you again the value again goes down, right? And then you are suddenly surprised, like what happened, like how like when you're counting it, how does the variation differ by by so much? And of course, this is an idealistic case. You would have some kind of noise in it, but here I have not considered noise. Right? It's just in my fictitious country there is no
Hmm.
noise. It's-
Right. Okay.
Everything works mathematically properly without any noise. So this is the
There's
trend.
no objection and such, right? I mean,
Yes,
yeah,
but this is the trend. And then once if you observe it, you might think that okay, something is wrong. Like how can this process differ statistically so fast, right?
right.
And then you would like to think about it, or to try to understand that behavior, right? And that is the thing that we will try to model today, and try to see if we can replicate such behavior, and if such behavior happens, why does it happen, what could cause it, right?
Okay, now we are trying to answer what happened in that short of time, why we have that abrupt change. So you will try to answer that.
Yes, I will try to uh, answer why this happens, what caused this transition here, right?
Right,
So when you see the TV, you just have these trends, but since we know a bit about system modeling, we'll try to model this trend using the knowledge that we have acquired so far, right?
right. To
And
me, it
also
seems
perhaps
so
learning new things along the way.
right. To me, it seems so fishy why we have that parabolic behavior in that interval. That's so,
Yeah.
yeah.
Let,
Okay,
and
probably you will answer that to us. Okay.
let's try to model and try, and we will try to answer it and see if that makes sense.
And
Uh,
that time, yeah, Francisco is asking why he can't see this figure in his notebook. Uh,
this is the thing is, I didn't want to give out all my cards at once, so I
okay,
wanted to create. I wanted to create to add new information when I'm giving live. So this is what uh, I came up with. No, me and Vedant were discussing before this session, and we thought it would be nice to have a plot like this. So we did some changes at the last minute, and I will send this notebook once the presentation is done. Right. Okay.
yep.
Uh,
Okay, Francisco, you will have it.
yes. Um, so before we start modeling, let me try to introduce the system to you. Right. We have the results. Before we start modeling, we want to understand uh, how does country X model works, right? We want to know that before we do anything. So in country X, we have a physical. Let me
Yeah, this
zoom it
looks
a
scary
bit.
every time. You need to explain what we are looking at here now.
Yes, let me open System Modeler so that the image is much clearer. No, I have not done it yet. Okay, so this is the model that we are trying. This is the model of country X. So in country X, you have voting by physical means. People go to the booth and vote, and also people can vote by sending mails, right? But the counting
Right,
takes place on the same day, right? And then from these two blocks, we have results, like from the physical block we have a result like which party is winning, what is the vote share, and from the postal block we also have the results, which party is winning, what is the vote share, and how many votes are present in respective blocks. And once we have that, you could see that we have just addition of how much votes party 1 got, how much votes party 2 got, and the total votes, right? And then we have calculated
okay,
the vote share. So this is
right.
on the top level, how the system works. Uh, and then if I go deeper into how a physical or a postal thing works, is in this case we already know the results, right? And we are trying to create a model to mimic uh, the behavior.
So, okay, what we saw on, let's say,
Yes,
TVX.
yes. So
Right,
we already saw the we already saw the output on the TV, and it created a question in our mind, and we are trying to model to match uh, what we saw, right? So
Right.
here in this case, let's say for the physical block, we have total eligible voters in the physical block, and this total eligible voters, they get distributed into party 1 and party 2, right? And we have percentage party 1. So let's say the in the physical block, party 1 gets 51% of the vote. Then here we mention 51%, and based on that, and party 2 will get 1 minus 51, like 49%, right? We have a
Right.
split between that, and then uh, we have a vote counting rate, like how many votes are counted per hour, right? And then based on this rate and based on this percent, we will have increase in party 1 and party 2 as time progresses.
Right. I mean, we see some familiar components from yesterday here, like
Yes.
party one and party two, and maybe total eligible voters, right? That
Yes.
also looks similar. But
So
we
we
have
will be Mhm.
two news, I guess one new vote party, the transition
uh,
component.
right. So the transition component, I think we have used it in the past. It's basically um, a rate component where you define an exogenous rate, or you can also define a constant rate, right? So and then in this case we have a input to it. So it's basically we are defining how much voters will go from the total eligible voters block to the party 1 or party 2 block based on a defined rate.
Okay, what is the difference between this and the block yesterday we used? What was it? Growth, I guess?
Yes, the block that we saw yesterday, the logical, the growth and the decline, they had an infinite reservoir inside
Oh,
them. So
okay.
they had a cloud inside them, right? So they were creating this the
Infinite
voters.
sources and things.
Yes, infinite
Okay, drain,
sources
yeah.
and
Uh,
sinks. But here we have defined
Limited population.
capacity. So now in this we are just using limited population. We're not adding
Right.
people. We're not considering migration or other things in this model yet. Of course,
Okay,
you can model
it is a
migration as
fair
well.
election, you're saying.
Yes. And one more component with that you might see is a we have a delay fixed, right? So sometimes when you model, there are instances where you want to time things, right? You don't want everything to start at 0 second. You want to be able to start something after a certain time, right? And
Right.
that control you can use using this delay fixed component that I have here.
It might also maybe because of the like if we consider a huge country, probably we might have different time zones. And because of that, let's say in one part of the country of X, we start earlier than the others. Or maybe we need to wait all of
There
them.
might be
Yeah,
several reasons,
yeah.
but this component adds us the flexibility to adjust when something happens, right?
Okay, yeah.
So it's used to time things, right? Okay, so now having explained what is the final objective, and then how a single block uh, looks like, and then trying to give the simple explanation of what happens. It's basically very simple. You have a big container, and then we are trying to divide the flow into two different containers with the rate that we are defining in this case, right? It's very simple.
Right, right,
The interesting dynamics happens when you try to mix different trivial components, right? That's where the real dynamics happen. And along the journey in today's presentation, in this today's session, we will also see that we have created a block because we have not seen such blocks before, right? In all our
right.
cases, we had a single model where we just dragged in the components, connected together, simulated, and that's fine. And we got the result, right? But as you try to scale up, as you try to add more scenarios, right, you need to create components, and that is something we will also look as we go along today, right? So with that, we had a lot of introduction. Let's get started with the modeling aspect.
Yeah, yeah. I guess everyone is waiting for that.
Yes. Okay. So let's open up System Modeler, and I will close my broken model. The model is broken because I did some uh, changes that we will do today during the exercise. Okay, so let's close this. So we will use the critical to data package, and under the exercises package, we will use the step one model. Right. So let's find the components uh, to represent the total eligible voters and party 1 and party 2. We will use the material stock, which cannot go below 0, right, which has a constraint inside it. So let's use that component, the material stock component, and let me zoom my screen. Okay. Okay, and then let me duplicate it twice to represent party 1 and party 2. Let's rename it material stock to total voters, then party 1, uh, party 2, and I'm pressing F2 to rename those components,
Right.
right? And party 2. Okay, so now we have our stocks in place. Now we need uh, the pump that would move uh, the number of voters from one category to the next, and that we can find under flows, right? And we will use unidirectional flow. We don't want a bidirectional flow in this case, right? So let's go to the unidirectional package, and then we can use the transition component in it.
Well, why we don't want it, Ankit? What is the physical meaning of bidirectional?
So there might be cases with that where you can have um, you can have
No, in this scenario specifically, what
Mhm.
would happen
Okay,
if we had bidirectional?
if we okay, we can use bidirectional component, the model would work fine, but there is no constraint in it, right? If for some reason we made a numerical mistake of a negative flow, right, then our model does not then our component does not have that constraint, and then we will end up with a wrong result, right?
Right, right,
So to limit our scope, right, that's why we use the specific components. We can, of course, work with the exogenous rate that we saw yesterday, where we had flow on both direction depending on the rate. But as you use those components, you have to be very much aware, because those could be sources of errors. Right? That's why
right.
we use a transition block for this, or unidirectional block for this. Right. So
It reminds me of diet, right? I mean, just one directional
yes,
flow.
a diode, right?
Yeah, a
Yeah.
diet.
Yes. Yes. Yeah. You can use that analogy. Okay. Um, so we have transition 1 and transition 2. Let's connect it. We will choose the connection line tool and connect the purple connector with this purple connector with white filling. And similarly, we will connect to party 2, then total voters through transition to party 1. And of course, the mass balance takes place automatically, right? Okay. Okay, fine. So now we have um, the basic blocks that we need, right? It's very simple. Total voters, uh, two other things, and this Vedat is so in system dynamics you have something called uh, material flow and information flow, right? Material flow, by material flow I mean here we have physical people moving between different stages, right? And then when we use this purple connector, we mean that this is the natural system, that people are moving from one block to the other. And
Okay,
then
yeah.
we have something called information flow. It is basically the logic that controls that movement, right? And you could see the blue arrow, which is called real input, and blue arrow out, which is the output. Those are those through those we can get the states, like for instance, how many, what is the rate, how many people are present in a container, in a block. We can get those sensor data. Then we can implement our logic using using some converters or or some mathematical
Right.
blocks, and then feed it back, right? So there is this information, so there is this logic and there is this actual material flow. And the
Okay.
thing is, this connectors are intelligent enough. So if you connect, if you, let's say, start connecting from a purple connector, I cannot connect to a information uh, output here, right? Because that does not make sense, because one is in the information domain and one is the actual material flow. So we
Right.
try to
But
avoid those logic.
what if it was the purple one, the Boolean input?
Still we The thing is, these equations have some variables in it, and if we don't find the corresponding variable in a connector, it will not allow it to connect, right? So there
So
is this.
having the purple line doesn't mean that we can connect every purple connector to each other, right?
Yeah, you're right.
Okay.
Also, uh, i I think I showed this last time as well. So if I connect the purple with another purple again, right,
Right.
what would that mean then? And you could see you get an error because you have already connected it, right? So you have already defined it, so you're doing repetitive connection, and then it does not allow it
Right.
allow you to connect that. Okay, Vedat.
So which means that in a way we have the, let's say, X number of variables in this system.
Hmm.
When we connect those, we say that the relation between these variables is this equation. If we try to connect them without increasing the number of variables, we are still adding new equations, which are exactly the same
Yeah, if you're trying
we
to
had.
connect it twice, then you're trying
Yeah,
to add like more equations, like the same equation, which are
right,
redundant. Okay, so let us see our diagram. So we have party 1, party 2, total eligible voters. Now let's start to add the logic to it. So you could see we have this percent party 1, which percent party 2, which are basically constant inputs, right? And then we have a vote counting rate, which is also, we will define like how many votes per hour and such, right? Okay, so let's get back to our model and let's implement those constant inputs. Okay, so to find those inputs, we can we have this information sources, right? So these are not material, but those are logic blocks, and those are informations, uh, and that we can find under the information sources
right, right.
package.
Ankit, sorry to interrupt you.
Mhm.
Right, Francisco. So when we connect the equations, we will see the connect function
Mhm.
in the text view, but it is just a front end. It will be treated as an equation when it
Mhm.
was sent to backend. It will be written as equation set. In Simulation Center, we have the equation browser where you can see which equations are chosen to solve your problem.
Right. So I don't want to deviate much, but I just
Yeah,
want to
so
show one simple example, a very hopefully a very simple example. Let's say we have this electric circuit example, and then if you go to the text view, you see this equations, right? And when we use the connect statement, um, this is advanced. I don't understand people to follow it, but later on, if they try to understand what's happening, for the later reference, I'm just mentioning it here. So what happens is when we connect two components, this connect statement is used, and what it does, it adds those mass conservation and energy conservation equation. And if you really want to go into detail of what the exact equations are, you can right click and then you can go to view flat Modelica. Um, right.
Right, we had also flat Modelica.
And here, if you go to view flat Modelica,
Ankit, can you
uh,
zoom a bit? Okay.
yes, I'm trying to zoom it. Yes,
Yeah,
and for people, most of the people can ignore this, but later on, if someone wants to know more, they can look into this equation, and here you can find all the. So for instance, at one junction you have register 1.pi, register 1.ni goes to 0, right? So here you can see all the derivative equations that has been used, so you can find all the model equations, and then you can actually troubleshoot. And this is very useful when you start creating your own models textually, which I don't think there is a need. I think there are components for almost all the components, and one can live without creating the custom blocks. But if anyone wants to do it, it's a good resource.
right.
With that, let's get back to our
Yeah.
to what we want to do now. Okay, so we want right. So we want a constant input to define the percentage share of party one and party two. Let's use a constant input, and we want to define a rate for the vote counting, right? And then let's use the constant input rate uh, component from here. Um, and let me just go back to my model. So we have percent party one and percent party two, right? I will rename this to percent party one, and then let me duplicate this by pressing Control D, which is percent party two. Uh, and then let's say the first party has 51% share, so let me use 0.51, and the second party has 1 minus 0.51, right? uh, Fine. And uh, for the constant input rate, let me rename it first to vote count rate. So now and then let's set the unit first. So I renamed it to vote count rate, and I want to set the value as or let me set the output type. It is 1 per second. The value type is also per second, so 1 per second here, and the value will change the display unit to 1 per hour. So with that, here we don't have in the display unit we don't have per hour. So uh, uh,
What can we do about it?
so the thing is, let's say if you have a model and you want to use per hour, or some unit that it's not displayed here, so how can we go about it? So the thing is, if we change s with h, so which h stands for hours, so then system model automatically understands and converts 1 per hour to 1 per second, right? So here I will just change s to h and then click OK, and here you see the display unit has changed, and let's say we have 20,000 votes that are counted per hour.
But that unit should be compatible with the second, right?
Yes,
Convertible thing. Okay. I
that should
couldn't
be
write the
compatible.
yeah 1 divided by Vedat, for instance. That
No,
would make
because
sense. Yeah.
because that because under the hood there are a lot of unit conversions, and if a conversion exists, then we try to convert it. If it does not exist, then we give an error that compatible unit does not exist.
Okay. Yeah.
So with that, let's say party one is having 51% of the share, and we are counting 20,000 votes per hour, uh, right? And
Great.
uh, okay, uh, right,
So what is our population then?
yes,
Should be
um, Yes. Okay. So now once we have the person party 1 and person party 2 and we have defined a rate. Okay. For now, Vedas, I will just remove um, the constant input rate function, um, just because I'm getting a bit confused with. Okay, anyways, it's fine. Okay, so now we have a constant input for person party 1, person party 2, and a constant input rate for vote count rate, right? Um, now, uh, so when the vote counting starts, the first party has 51% vote share, right? So if I try to count in terms of votes, so it will be a multiplication of the vote count rate time person party 1. So I would just take a product, um, take a product of those two values. And to do all those to do all those calculations, we have something called converters. So inside the converters, you can do a lot of computations. Like you can do an absolute value of things. You can add multiple connectors. You have things called clip or you can have guarded division to avoid zero errors. And you have a lot of other functions that you can make use of. For our case, we will use the product, and you can see product uh, 2 is there. If you have, if you want to take product 3, if you have 3 inputs, you can take product 3, but let's, for our case, we will use product 2, right? And then once we have that, uh, let's connect our person party 1 to the product, uh, right? And then let's connect the output of the product to my transition 2, and let me connect the vote count rate to the product 2, right? And so what I'm trying to do here is we have a percent for party 1 vote that is counted per hour, multiplying it and then passing it as a rate to my transition block, which will move between total voters and party 1, right? And similarly,
Right,
I duplicate my product 2, and then I connect to transition 1. uh, I then I calculate, I take it, I multiply the person party 2 with the vote count rate, right, to get what is the share of the second party, right? um,
right.
right. So and the total voters, as you mentioned, let's say we have 1 million voters in our country X, right? So we have 100 million. Yeah, we have 1
100
million.
million. Yeah,
We have 1 million. We have 1 million voters. We are counting at 20,000 per hour. And then for the first party, we have 51%, and for the second party, we have 49%, right?
right.
The
Also,
simplest.
Ankit, we had the question of
Mhm,
right. So we have each and final after the units. So
mhm.
maybe we can talk about a bit quickly here.
Um, uh,
So yeah, I can explain if you like.
was it this after the unit,
After the unit,
or
well,
does final each mean
yeah,
after the unit?
person. I guess in weight, what count rate over there we had
Okay,
that,
okay,
right?
okay. So,
Yeah,
okay, fine. Okay, let me explain this. Um, so let's skip each for now. So what happens is when you have arrays, right? So when you have arrays, and then there might be instances that you don't want to assign the same unit to all the array elements. There might be cases, right? But in most cases, you want to define the unit for each element of the array, and there you press each when you, and that is basically when you use an array of a list of when you have array of elements,
everywhere.
then you use each. Final is when you set something to final, and let's say someone uh, copies your model and tries to build upon it, so they will not be able to change the display unit by themselves, right? So when you make something final, uh, you avoid people overriding the unit, and also this is something you don't need to use it. This is important when you create your own library. So when the library developer, a business simulation, he created his library, there are some things he doesn't want you to change, and those things he will set as final. So people using his library will not be able to modify it. Right? Okay.
Right. Yeah.
Okay.
So
So
it's in a way prevents us to do unwanted things by the developer.
yes,
Okay.
yes. As I said, when you start modeling, all are equations, right? And if you don't provide constraints, things might fail in very unexpected ways.
Right. And all those things, all those constraints have some physical meanings.
Yes.
Yeah. And we don't want to violate them. And that's why sometimes we put those
Yeah, because
constraints.
sometimes maybe the library developer is using an empirical relation which has some type of unit that is used, and he doesn't want you to change those things. That's why there can be various logic involved in it. Okay, so now we have a very simple model: total voters, party one, party two. We have defined a rate, um, and we have defined some percentages, right? Very simple up to this point. Now let's set the experiment setup. Um, we will simulate it, let's say for 2 or 3 days, right? Let's say for 3 days, and click OK, and let's simulate. Because at this stage I just wanted to verify how my vote count rate component is working. So that's why I want to simulate at this stage. So whenever I feel that I'm not comfortable with one of the component, I try to create a simple model as possible, try to simulate it, and try to understand that component, then move ahead, right?
Right. That is also another practice, Ankit, where you can hint us about
Mhm.
that. So how we can debug big models. So in
Okay.
a way, you talk about it now.
Mhm. So let's say we have a lot of components here, but let's say I just want to understand how my vote count rate works, right? And all these other models are just details, right? So
Right.
what I could do is, what I usually do when I try to debug is I right click and I disable the components which I don't need, right? So let me disable this, because what I want to know is whether my vote count rate is actually working as I expect, right? So here you have 20,000 votes counted per hour, and here I can change the string to per hour, or I
So,
can just
but
avoid
we
the
we
string here.
talk about let's debug it, but we don't know when the model is, let's say, broken, right? So,
Yeah,
how do we know our model is broken at the first
um,
place?
right. It's basically, if you see the results, and let's say some value has a very weird scaling, you're getting something like 0 into e to the power 23 or something weird, right?
Right,
And
but thanks to you, whatever model we created, everything works perfectly.
no,
So
you
you
might ask
haven't created
participants and
any.
they would have a different
Yeah,
opinion. I'm
yeah,
sure.
but I mean, what's the other? So here we have like a next to the play button, run simulation button, we have like the validate.
Oh yeah, right. Okay, so sometimes what happens is, you're right with that. I didn't cover it. So let me validate my model. I might have activated units, so there might be some unit errors, but let's see. Uh, right. Yeah. So the thing is, um, before uh, let's say you have created a model, and let's do a mistake knowingly with that. Let's say I have
Right.
not I have not connected my component, and it's an oversight. Like, I was creating my model, I forgot to connect it, and if I simulate it, I will get an error, right? But how do I test as I go along, that is everything all right or not? So if I remove this connection line, so now I have an imbalance equation, right? um,
Can you show us?
I hope that's I have an imbalance equation.
Yeah, it
Let's try
should
to
be.
see. Uh, yes.
Yay! It's
Yes.
broken.
Yes, I was able to create an error here. So you see, I get an error that variables not solvable in any equation. Transition 1, port B, dot stock. So the thing is, we have a dangling output which is not connected to something else, and we have some imbalance in our equation, right?
Right.
So through this, sometimes this messages would be very cryptic, but what I try to, when I read these messages, I try to find which component it is hinting me towards. Right here, it is hinting me towards the transition one component, and here you could see,
Right.
if I see this component, I can observe, I have not connected it, and that might be the cause for it, right? So let's use the connection line tool and fix our model, and then
Um,
validate again.
and I want to also
Right.
propose another way of
So now you
creating
see
broken
that.
model.
So now you see my model is balanced. Yes.
Right.
Okay.
What happen if we, let's say, overlook one of those blue real inputs? Let's say we just
Okay. So
haven't
this
connected.
one,
Yeah, yeah,
if you don't
that's what
connect
works.
it, yeah, I think you should be getting. Um, I'm not sure actually. Let's
I
see.
would expect a balancing error.
Yes, you are
Yeah,
right. So we have a balance. It is not balanced. We have 19 variables and we have 18 equations.
right. We
Right.
can also look which equations we create by using the flat Modelica here, right? Can
Um,
we?
I don't. I don't think so.
So
I don't think so,
I guess
because the thing
let's
is,
see.
when you do flat Modelica, I think it validates the model, and if there is an error, oh, we could. This is something new for me. I didn't know. I didn't know this. Uh, but yeah, uh, you can have access to those equations. I'm not sure how we
Right,
would debug it uh, right
right.
now, but
Now it looks quite challenging. But yeah, for smaller model, that would work really nicely.
yes, yes, yes. Okay, Vedat. So let's let's
Yeah, yeah.
carry on
Sorry, sorry.
on our journey.
I
But
interrupt you
I
a lot.
think but I think it was nice that we showed something that is an error. People see that it's not always a pleasant journey. You will
Right.
get errors, and when you get errors, there are ways to start troubleshooting. Look at the flat Modelica, try to disable all the component that you don't want, and try to mod simulate it and try to see the results. Okay, um, right. So let's simulate this model because I wanted to check whether my vote count rate works as I expect before I move forward. And then let's go to two and let's plot. Right. So we have only 200 votes that are counted in 3 days, right? That doesn't sound right. If I look into my vote count rate and the output value of it, and then convert it to per hour, and
How
convert it.
can we do that? We couldn't find Ankit
Yes. So here,
over there.
one you could see that I don't have per hour, but I want to verify my output in per hour, right? How can I
Right.
do that? So there is a way of doing it. So if I right click on my y-axis, go to display unit and go to custom,
Oh,
right?
thanks, man.
And if you go to custom, and then if you select H as we did in the model view and click OK, then you could see that I have my vote count rate here. And here you could see my value is in 5, but I had a value of 20,000. So let's
You
go to
had
the
value of
parameter.
20,000. Wasn't it for a day or it was for hour? Okay, yeah. Yeah,
Yeah, it
there's
was
something
per
fishy here.
hour, right? So there is something wrong with the conversion of my units here, right? Okay, let's try to see if we can figure it out. If not, we will try to use a different component. So if I
Right.
select my vote count rate, I see that my unit type is in rate, that is in per second. I have my value type in per second, and I have the value as 20,000 per hour, right? And my time
Right.
base is in hour. Uh, let's try to change this to seconds, and let's try to see if maybe that is what causing it. I don't
Right.
know. I don't know what might be causing it. Let's try to simulate it now. Right. And now you could see I got the right the 20,000 per hour in my y-axis, right? So
Right.
you saw with that, like I was reluctant when I did this model, trying to change the time base string, which and it mentions here that the default should be in second, but I thought something is not right, and I changed it to hours, which led to those error, right? So
Right.
um, uh, this was a bit confusing for me, and the only way to try to understand this was to try it out, and then try to change the string and try to see if it fixes my error or not. And in this case, it happened to fix it.
Right. Also, one can read the documentation if any info written about it
Yes,
to understand how the developer of the library thought while developing the library.
yes, uh, yes, and probably there is some information about it which I forgot,
Right.
because here you
There
see.
might be or might not be.
No, there is. So you could see here, he has written, the developer has written, the output will always gives rates per second, but rate can
Right.
be entered in non-SI units of time using the parameter time-based string, right? So what it does was, this 1 per hour was converted to per second, and then there's something weird happened. So I think the best way is to keep this in the default second, and then try to change your hour. And we verified this when we created our model, right?
Right.
And that's the only way when you deal with components from other libraries, you don't know how the developer might have thought about the component. Okay, so now once we found a bug, we try to troubleshoot it, we have fixed it, right? Now let's scale up by activating our other components. So right click and uncheck my disable component feature, uh, and then I will right click and I will uncheck the disable component. So now all things in place, let's simulate our model, and you would see a linear growth for party 1 and party 2, which would get constant when the number of votes have all the votes have been counted. So let's
Right.
remove this. So now once we have the simulation, let's plot the vote for party 1 and party 2. So now we have vote for party 2. Let's plot the number of votes for party 1. Let me drag it and put it in the same plot. uh, Wait.
To distinguish, maybe you can show
Yeah.
us the how we change the color here.
Yes. So what happened was, when I dragged from one plot to the other plot, it could not it did not it copied the same styling that I had in my previous plot. And let's say if I want to distinguish it, right? If I have multiple plots in it, how can I change the plot properties? To change the plot properties, I will double click on, either I can go and right click and go to properties, and then uh, uh, right. And then if I go to the data set, so once I select my subplot, go to the data set, and here I can select, let's say, orange in this case, and click OK. And here you could see I can change the color of my plots, right? Just to repeat it again, I right clicked, went to properties, went to data set, and selected party 1. And then if I select party 2, I can also change it to, let's say, red. And I can also change the line styling. If I want a dotted line, if I have multiple curves in place, I can use the dotted lines, click OK, and then you could then plot it, right?
Ankit, can we put a probe there to measure the data? So
Yes,
let's see
sure.
whether we
So
miss any
let's,
vote.
at 2.5, let's say we measured, we put a measurement probe by pressing Control plus left click, and then let's also plot. It would be nice to see the our total
Summation.
voters
Yeah.
count. And here you could see we started with 1 million, We went down, and now there is everything has passed on to the two different buckets, right? Okay, so our
Right.
component works as we would expect. The only thing missing with that, that I told you that we will use, is the delay component. So now if you look at the results, everything started at time 0,
Mm,
right? But
right.
how can I add a delay? Like, let's say I want to force the system to start after 1 hour, and that you might use if you have multiple systems in place, and each system you want to give a different starting time during the simulation. How can we do that, right?
Yeah, Ankit, how can we do that?
So for that, I think
It was
let's
really challenging. I remember while taking the courses, I mean, in state space or transfer function, modeling the delay, it was always challenging. Maybe you might have a nice trick here.
I don't have a nice trick. The library has a nice trick. so
Okay.
so if you look into the converters block, we have something called discrete delay here, right? We have a discrete
Okay.
delay package. And if I go inside the discrete delay package, we have a delay that is fixed. We have different other types of delays as well, right? But let's use the fixed delay where we know how much time we want to delay it by. And let me drag it here. Uh, and I will put it after my vote count rate, because I want my voting to start after a certain time. So I will use it with that input. And let me delete this, delete all the, sorry, delete the connection lines and put it here. And once I put it in series, let me connect all the other remaining components. Okay. So now in delay fixed, if I click here, you could see I can set a delay time, right? Let's say I want to set a delay time of 5 hours. But first, let me change the display unit to hours so it's easier for me to check. So I will select S, go to display unit, select H for hours, click OK, and then let me select 5 hours. So I want things to start after 5 hours, right? Okay.
You mean the counting will start after 5 hours?
Yes, I want the countings to start after 5 hours. So now I have a delay fixed using that. Let's simulate our model and see how our model has changed. Okay, Vedat, do you have any questions from the audience that we can take now?
Uh, I think we are doing good.
Okay, so
Yeah, folk
let's,
seems happy.
right.
And
So what I think what this I showed. So whenever we want to change the display unit in our axis, whether it is the horizontal axis or the vertical axis, we just right click and change the display unit to hours, right? Because in this case, I wanted to have it in hours so that I can verify. And if I zoom in into the first 10 hours by left clicking and then selecting what I want to see, you could see that my process has now started after 5 hours, right?
yeah, this is really cool, Ankit. It is way easier than what I was trying to do. Yeah, in my undergrad years.
Okay, fine. Right. um, right. So now we have verified our component. We have added the fixed block to it, right? And so Vedas, let's say that if I return back to what we wanted to model here. So now what we have modeled is, let's say in the physical, when we are counting the physical votes, as we are doing it
Right,
after the voting has already been over, we know what is the distribution for the physical votes, right? Which was
right,
51%
right,
and 49%. We already know it. And from here, we had two different blocks where we know what is the total number of votes for each party after the simulation
right,
has finished, right? Now we want to add a, process which is very much similar to the physical block for the postal part as well, because in the postal part you also have a total number of voters, and then you have a distribution, like for party 1 gets X percent,
right.
party 2 gets Y percent, is exactly the same with different parameter values, right?
Okay. So while you are underlining exactly the same, Do you have any tricks for us,
Yeah, yes.
or are we gonna copy all of it?
I think that the trick is to think about it as the trick is Control C, Control V, and then
Okay, yeah,
create a big block and then try to confuse yourself. No, so there is a trick, uh, and that is the power of using components, right? So you can think of components as functions. So a component is a function. You define it some parameters at the top level, and then it gives you some output based on those parameters. And then any other user can use that component as a function, as we have been using all these different blocks, which are something like components. If I click over one block, you could see I can define some parameters to it, and then it does some operation, right? It has a behavior inside it, right?
right,
So when we want to repeat things, like in this case, the physical, the voter pat, the system, we want to repeat it for the postal as well, right? So it is much easier to scale up by creating components, right? So now let's go ahead and start creating our component, right? Is fine?
right. Yeah, that sounds quite promising because now here not every country has only two parties running elections, right?
Yes. Uh, I think without that point, the image is broken now, but that point becomes much like you can stress on that point a lot, because you can imagine that this is for one state. In one state, you have a physical, you have postal, you have one pattern. Imagine you have 10 different states,
Right,
right? So rather than duplicating this 10 times, you create it as a block, and then you have 10 different blocks. And if you get more advanced later on, you can always create arrays of blocks, but that is an advanced concept which I will not cover today. But that
right.
but there the importance becomes much more apparent.
Right. This is also what the system modeler is really powerful, right? Because it's a object-oriented way of modeling
Yes,
a
that allows
hierarchy.
that allows one to scale up, and also it allows one to do repeated testing, which is the unit testing. So rather than creating a big block, you would create a small component, test it, and then create another component, test it, and then combine them together. So that
Right,
way you develop small things, you test it, create bigger models, and that way it makes it convenient to scale it up. Okay, let's get
Before
started.
continuing, Angit,
Mhm.
Helmut is asking what was our unit for the vote count rate?
Right. For the vote count rate, I used 1 per hour. So here it was in seconds. I changed S to H, and then I changed the display unit to 1 per hour, and then I changed it to 2000 or 20,000. And I also changed my value type and output type to dimensional rate flow 1 per second, and similarly for output type also 1 per second. So
Okay, yeah,
those three things I modified, and I kept my time-based string to seconds as it is. Right. So those are the three things that I changed. Okay. So before so let's save our step one model, uh, and then let's try to create a new model inside our components package, right? Where we will copy this where we'll copy this model and then we will reuse it. Or yeah, or one other way could is also like just drag step one, take it into components, and then it will create a copy for you directly, right? And I don't need to do anything else, right?
okay,
So now I've created a copy which is called step one. Let me right click and rename it to something more meaningful. Let's say vote counter. Let us rename it to vote counter, right? And you might see that the name that I have used here is with a capital V, right? and that's a convention that I typically use. So when I create a component, I'm creating my own function that can be used at other places. So when I'm using my component, I start with a small letter. As you can see here, total voters, T start with a small letter. But when I'm creating my component, which I plan to reuse it later, and those models it start with like capital letters.
Okay.
So that's a convention that I typically a lot of modelers use.
So Ankit, why didn't you name it like physical vote counter? Why you pick
I wanted to
a
keep
more
it a bit.
generic thing?
I wanted to keep it generic because I will be using it for physical as well as the postal thing as well, right?
So it is a generic thing. It is a bit, let's say, the base thing, base class thing, and we will use it for different purposes.
Yes,
Okay.
yes, yes. Okay, so now there are two things that we need to do if when we create a component, right? When we create a component, we need to define outputs, right? What do we expect out of our component? From this vote counter uh, block, we want to get the value of what is the votes by party 1, what is the votes by party 2, and how many votes have been counted, right? So imagine if in the global model, we will take all those total votes count and we will have a global picture of what's happening, right? So we will have three different outputs: vote from party 1, vote from party 2, and the total votes that have been counted. Okay, right. So in order to create an output, you could see in party 1 we have this the green the triangle, right? And this is the output connector which tells us the value of the stock, right? And this is the out that this is something that we want as an output. So to create an output, what we would do is I will select my connection line tool, select uh, the triangle, and then create a connection line and right click and create connector. I'll press create connector, right? So connection line tool, just drag in the connector and right click and say create connector, right? And then I will click F2 and then I would rename it to vote uh, party 1, right?
Right.
Uh, Let me zoom out and do the same thing for party 2. Select the connection line tool, uh, start a connection line from the triangle, right click, create connector. We have the connector now, and if I do F2, I have vote party 2. Okay, so those are the two outputs I have now. The next thing that I want is I want the number of votes that have been counted, so that at the top level I can sum them up. To create that, let's look at our model, how we did it here. So here you could see we have the vote counted, and we took a negation of the number of voters present inside our total voters container, and then uh, we subtracted it with the total voter count, and then we got the total votes out of it, right?
Right.
um, so and the reason I do it is because um, there is no subtract component uh, inside this converters. So one way of doing the subtraction is by negating it by -1 and then summing it with the total voters.
Okay, okay, Ankit, couldn't we use, I don't know, maybe from block library, blocks, Modelica blocks, we have like a subtract, right? Do we have there?
We don't have subtract without. If I search for it, you see we don't have something called subtract.
Maybe,
What we
okay,
have is an add, and in that add in the Modelica library we can get -1.
Right. So we can get our own yeah, subtractor by modifying it.
Yes. I think it's also nice that you brought it up. Let's try that out. Let's
Yeah.
say, because I said, as I mentioned, these are just real signals, right?
So yeah, actually that was the thing I just wanted to ask. So here we were using all the components from the, let's say, business simulation library.
Mhm.
So how can we connect to something more general?
Yes. So the thing is, if you have so there are two types of connectors here, right? One connector is the purple connector, which is for the passing of people, voters from one category to the other. We cannot use it with real connectors because that is not the right signal or the right output. But we have the Modelica blocks library where you have the discrete, the continuous, the integrators, and all those mathematical operations are already there, right? We can directly make use of that as well. So this library is compatible with with the blocks library as well. So let's say you want to use um, a continuous a component from this block library which does not exist in the business simulation library, right? Even so, in that case, you can make use of this because it's just real signals
Okay.
that comes out of it. Okay.
So how can we understand it was it would be a computable output?
The way to understand is to just try it. So let me just rename it um, to something like subtractor.
Mhm.
It maybe it should be vote counted so far, but let's see. Uh, okay. So now, as a first input to try it out, the is just to use it in a model and try to see if
If
system
it's
modeler
correct or
complains
not.
or not, right?
Okay.
If it does not complain, then it's fine. That's the first way of trying it out. And the
Right.
second way is then you simulate and see if the results match what you would expect, right? Okay. So let's take this and see there is no complaint. So I can connect it,
Right.
and then I want to subtract it from the total number of voters, right? And um, for that I will need a constant source which would store my total number of voters data, right?
Right.
And for that,
But wasn't that what we were looking? Okay. Okay. You are looking for something constant.
yes, because here I have defined the total number of voters as a parameter, and that value will change as time
Right.
progresses, right? And what I want is how much it has changed from its initial value, right?
Right.
And then uh, for that, either I can just duplicate my percent party, which happen to be a constant input source, or I can also use a source from the sources block uh, if I want to continue on your journey of combining it from other libraries, right? because
Right.
because sometimes it might happen that so you're so used to this block library, you're used to those components, you want to use that instead of what is provided in the library, right?
Right.
You of course lose out some features like the output type and other things, but in some cases it might be okay. Okay. So
Yeah.
now I will rename it to total initial voters. Click OK, and then this value is 1 million, right? And then let me connect it here. So here you could see it's still, if I click my subtractor, I have plus 1 time plus 1. So what happens is I will change this the k1. So if I hover on my connector, it says u1, right? And the k1 parameter corresponds to that u1. So it's basically the same thing. I'm actually multiplying -1 with the current value here, and then adding it with my total number of votes, right?
Right.
So I'm getting the difference, right? And
Right.
now I want it as an output, so I right click and then create connector, and I would rename it as vote counted. Right. Okay. Fine. So far we have added three different outputs from our model, and if you see, there is some weird thing happening in our icons. It has
Right, we
three
have small
different.
teeth there.
We
What
have
are those?
small dots here. What
Yeah,
what
that's
what,
like.
what is happening there? So let's go to the diagram view, or the icon view. Sorry.
Mhm.
And to go to the icon view, either I can press Control+1, or I can press this icon view symbol here. I go to the icon view, and here you can see the different outputs that I have created. And if I hover over it, it says vote party 1. That is an output signal. And similarly, if I have vote party 2, and then I have vote counted, I'll place it here, right? So now you could see
Right,
that those three are the outputs from my component, and I can place it here, right?
right,
And I can create my own icon. I don't like the rectangular, this the circular symbol here, because it represents an example. So I would select it and delete, and then I can create my um, own icon for it. Like, I can use the drawing shapes here, and then I can create my own icon like this, and then I will select it and give it a fill. Click OK, and then oh, this is too bright. Right. Okay, so now you can do all other modifications. Like, what I typically
right,
do is I find a nice SVG, or I create my own SVG, and then I put it here so that when I scale it up, it doesn't break and it looks nice. But of course, you can
right.
make use of the drawing tools, and then you can create something, right? And you can
Likewise,
create
you
your own.
did in that coffee mug example, right?
Yes, the coffee mug example, I just added a
Right.
SVG image to it, right? And then you can play around with it. Okay, so with that, now we have created. Why was it in exercise? Okay, maybe I was using the wrong model.
Okay, might be.
Okay, anyways, let me delete my vote counter. So I modified my step one model instead. Okay, so let me let me keep it as it is. Okay, so now we have our.
Maybe
Um,
we can just
yeah, I will
copy
just
that,
delete
yeah,
it.
yeah,
Yeah, that's, and then put it under components.
and rename it.
Yeah, um, vote counter. Okay, fine. So we now have our, I will just close it down. Yes. And to avoid any clashes in the future, I will close the other
Mismodeling.
things, the close the other component or other models that I'm not using. And to do that, I will right click on the upper tab of a bar here and close all but this. Right. So I am just working with this model that I'm interested. Okay, Vedat. Now we have defined our outputs, and you could see in the icon we have our outputs aligned here, and then we can put a nice icon or a text describing what our model does, right?
Right,
What our component does. The next thing that we want to do is add some parameters, right? So now we have our model ready. We have the outputs defined. We need to make it repeatable. Like, if I want to change the vote count value, I have to select the component, go to the value, and change it, right? Similarly, if I want to change my vote share, I have to click on my on my component, go to the value, and change it. So if a user is trying to use your component, it would be a hustle, right, to
right,
change all the individual values, and then they would not know what is the right value to change, right? So it is nice to have some parameters at the top level, right? And that we can trickle down into all the other components, right?
Top level in this instance, like we did here, these outputs, right?
Yes.
Uh, those outputs also become top level because we had also another small
Oh,
icons, arrowheads, which we
yes.
don't see at our model
Yeah.
because
Like,
those belongs to the subcomponents,
yes.
not the top level.
Yes. Uh, yeah. Yes. Okay. So now in the top, and to get to the top level, you click some anywhere in the canvas, and you see in the general you have a blank screen here, right? And now let's say for this component, I want to define what is my vote count rate, when should my vote count start, and what is the share of the percent party one, and then how many total voters I have, right? Those are the four
Right,
parameters that I want to have for my generic block. Let's quickly go ahead and add those things. To add a top level parameter, I can right click, click add, and select parameter, and let's add those parameters. So we have total voters, and I would click add. Okay, so I cannot, no. So the thing is, my name clashed with one of the component name. Hence, I'm getting this error here, right? So
right.
I don't want to overwrite it. Total voters, uh, comp, some total voter, total eligible voters.
Numbers, maybe. Yep.
Yeah. Yes. Okay. Total eligible voters, and then you could see that this parameter has been added at my top level, and then I would add percent party one, right, param, just to distinguish it from my component name. So now you see the second parameter has also been added, percent party one param, which represents the parameter. And the third thing is the vote count rate, the vote count parameter, and then the last thing that I want to add is vote count start time, right,
Right.
and close it.
Ankit, this seems a bit challenging to hard to track of, like keep the track of, right? I mean, isn't there any more visual way to do that? Isn't there any?
Right, there is. This is one way which, as you said, is a lot of work sometimes, right? One easy way is you click on, let's say, the total initial voters. You click on the parameter which you want to move to the top level, and then you left click on the parameter that you want to move, and then there is a option called lift parameter to class vote counter. And when you
Okay,
when you do this, you can specify your name here, like total voters, something like this. Yeah, one. Let me.
so yeah, yeah, total voter number.
Yes, something like this. And then you could see that this the parameter automatically went to the top level.
Right. It even comes with the description
It
for
even
that
comes with the
file
description for that. Uh, uh,
and also where it's inherited from. Because it's
yes,
inherited from.
yes,
Right.
I just deleted that. So let's remove all the other parameters. So that is one way of doing it. But as you rightly said, perhaps that is the easier way of adding the parameters to the top level, right?
Right.
So let's go to person party one and do the same here. Uh, Maybe say val party one, click OK, and then you could see the value moved up. And then for vote count rate, I have the value. I left click, lift parameter, and value or I will just say val vote count, and for the delay fixed, I will move the delay time to the top. The same process, left click, lift parameter, delay time, click OK. Right. And now you could see as it was so easy for us to move the parameters now from from the bottom level, from the component level to the top level here, right? And it also gets the units, so I don't need to define those again,
Right.
right? Okay, Veda. So now we have a val party one, which says the percentage for val party one. For the party two, I will just subtract that with one, right? So now, since we have only two parties, and then
Right.
we have vote for one, so we automatically see what is the vote for the second. We get
Right.
we get there, and also for total voters, uh, I will change this value to total voters one, total voters one, to match the top level value. So here we have total voters one, and for this initial value, we also have the total voters one,
Right.
right? So let's check again. We have for the party one we have defined, for percent party two we have defined, vote count rate is defined, delay fixed is defined, and the initial voters is defined, right? So we have all the four parameters that we need for this, right?
Right. Ankit, can we say that we have roughly 10 to 15 minutes to,
Yes, we
yeah,
have.
finalize the session?
Yeah, this was more involved than I had initially thought, so
Yeah.
it will take 10-15
Yeah.
minutes more to finish it.
Yeah.
But let's finish. Let's get ahead. Let's start and finish it. Okay. So now that we have learned how to create a block, we have we have the components, we have defined the outputs that we want, we have defined the top level parameters, and as Vedat mentioned, you can make something top level by left clicking on the parameter and then clicking lift parameter to the class, right? And it brings to the top level, right? So now we have a nice vote counter component that we can reuse several times, right? So let's go to step 3 and try to create different copies of our vote counter. Vote counter here and vote counter second. One thing that you might realize with us, we don't have a name here, right?
Right.
That is missing. In order
How can
to,
we add that?
so to add that, we have some special constructs. So if I go to my icon view and I select the text uh, symbol here, the text tool, and then I can create a text. And here to get the name of the component, we have a symbol called percentage name. So it's called percent. Uh,
Yes, you
where?
are not writing.
Yes, I am looking for a percentage sign.
Shift 5, maybe?
Oh yes, percentage name, and then click OK. Uh, so right, and then
We
I will
can
just
change the font.
yes,
Wait.
yeah. And let's get back to a step one, to step three. Sorry. So here we can see now it has got our vote counter one and vote counter two, the default names. So what I
Right.
did was I went to the text icon view, added a text cell, and then in the text wrote percentage name. When I wrote percent, it tells me that it is extracting the name of my component that is defined, right? So uh, I do that, and let's go back to step 3. uh, right. So now with us we have our two components. Let's rename it to postal and physical. Postal, and the second one we will have physical, right?
Right.
And the next thing would be to do the accumulation thing, to do the summation of different things and calculate the vote share, right? uh, to to save time, I will just copy, if that is all right.
Right. I guess we did this thing already in the earlier model, right?
Yes, the
Yeah,
only thing that we didn't do with that is the vote share 1 and vote share 2,
I
right?
see.
And let's say if I want to see where this component is in my library, I can right click on it and say go to class in class browser, right? If I click here, go to
Okay.
class in class browser, it it opens the component here. So rather than going and
So
searching for it, I right clicked, go to class in class browser, and it points me out to to where the component is located.
right. Also, when you hover it, we can see where it belongs, right? We can see the full
Y-
address.
Yes, if I hover over it, it says business simulation dot converters dot division guarded and vote share one,
Okay,
right?
that also belongs to business library,
Yes,
business simulation library. Okay.
yes. So now let's sum for party one. Um, so let's do all the connections. So we will select the connection line tool, and if I hover on my connector, it says vote party one, right? So that I can distinguish.
Right.
So I can
We
easily,
can
so
see, yeah, which output is that.
yes, and let's connect it here. And similarly for physical, I have uh, for vote party one. So that's done. I don't like it. So yes. Then for vote party 2, we will connect it, right. And then for total vote counted, we will connect the third connector together and we have total. So what we have is we get the current value of the total number of votes party 1 got, similarly the total number of votes party 2 got, and we will divide it by the total number of votes, right? But with that,
Okay.
both are the same now. We won't see any difference.
Right, right.
Let's add,
So,
let's keep the default for, let's say, our physical, let's keep the default values, and for postal, let's say we have 500,000 voters, right? And
okay,
then let's assume that in the postal part, the party one is actually losing, and let's say we have 0.47, and this is basically from the data that is already obtained from the elections, because we are doing a post election process, right? So we know those values.
right. We are just trying to understand the phenomena.
Yes, yes.
Okay.
and,
Replicate
and
the phenomena, let's say.
yes, and let's say, Vedat, that uh, the physical votes are counted uh, after some delay, right? Because maybe the vote count for the physical process is a more time consuming process, so it starts early, but for the postal part, maybe it starts at after some delay. And then uh, so let's try to have different parameters for it, right? So we have a different stop time or delay time for our postal, and let's say that it has a different counting process which is much faster as compared to counting votes um, in the physical counting, right?
Right,
Or the yeah, and let's say it's 5 times faster, so it's like 100,000 uh, per hour. So the counting of the postal votes is completed within 5 hours, because it's easy, it's easily compiled, and it's easy to accumulate, to sum it up, right?
right.
Okay, so now let's simulate and try to see how our model responds. I forgot to set the experiment setup, so that is something that we might need to adjust now. Oh,
Oh,
okay, I got an error.
so let's see. What
Let's
is that?
start with the vote counter component and let's try to validate this.
Why we are trying that?
Right, because this is the first thing that I did, right? uh, so here I get an error saying that invalid component reference parameter model settings is not part of the model, right? And if I click here, it tells me the minimum is, so when I lifted my parameter, there is this setting uh, which was also lifted along with my model. So let me just delete it for now. Uh, and let's get back to the model, because understanding that error is
Right.
another 15-minute task. Uh, and let's see if it fixes. So okay, now my model is balanced, so that I validated it. Now let's go back to our step 3. I'll close all but this. To our step 3 model, let's validate this again. Right, so now it says it's globally balanced and there is no error in my model. Right, let's set the experiment setup for this in days for 3 days and click OK, and let's simulate now. So what I did now, Vedat, people might um, perhaps we can explain it tomorrow or day after tomorrow, like when we get an error, how to troubleshoot that error further.
Right.
Right, so because I think that will need a separate 15-20 minutes on its own. And now let's plot the vote share 1
Oh, we see something fancy
and
happening
plot the
there.
vote share 2. And let's just uh, zoom into this part here. Right, so this is and then let us do a subplot and plot vote share for party 1 and vote share for party 2 together. uh, right, and then another subplot for total number of votes that are counted. Right, so what this shows with us here, that up to, let's change the display unit to hours so we can talk in terms of hours. So at 5 the voting started and we were just counting the physical votes which had one type of distribution in it, so it was following a particular trend. But after 15 hours, when we started when the process uh, when the ballot counting started, it
Hmm.
had a different distribution in it. Right, it because in that
Distribution is okay. Yeah.
distribution, in the sense the party 2 was winning in that case and party 1 was losing. Right, so we had a different
Okay.
behavior
Yeah.
there. So now and this behavior depends on the total number of votes in one group and what is the percentage for party 1 and party 2 in one group. And when we combine to mix these two different substrates or these two different groups together, how is the cumulative thing behaving? Right, and
Right.
that's what we are observing here.
Yeah.
So
It.
when
I mean, I would never imagine that such a behavior would be end product of this linear counting process.
yeah,
Oh, it is so
this behavior is
surprising.
was a bit surprising, because all the curves here you could see are linear, but when you're calculating the vote share,
Right. Right.
you get this different behavior which you might not expect in the first go. Right,
Right. And also the article you share, I mean, it is almost impossible to win that thing. So in such a, I guess what they're trying to say in such a short time of the period, because both, let's assume this physical and the postal, they have different rate of the sampling rate, right? I mean, we are counting it and we are saying that let's say every hour, uh, let's say 100,000 votes we count them and we adding those numbers to the total numbers.
right,
And when we look at that short of time, and if we do the math and getting, let's say, in a, let's say in 100,000 votes, let's say party one gets 600 of them. So when you do the math each time to likelihood, I mean, you are just multiplying and doing the math, and statistically, you are saying that in that short of time period, it would be almost impossible.
right.
So, but when you consider different dynamics, like okay, we have a postal and we have delay, and we
Yes,
have a physical.
yes. So that's the thing. Like once you observe the data, right, it doesn't make sense to you when you see it in the first go. You try to understand what is the system behind it, try to come up with very simple models that are behind it, and then try to combine the two processes. Basically, you can think of about it as a chemical process where you have two different immiscible mixtures coming together, and what is the final concentration in the final chamber, right? So it's kind,
Right.
you can think of it in that aspect as well, and then you can try to model the dynamics. Okay, with that, let's try to conclude by summarizing what we have seen so far, right? uh, so today we saw uh, how to create this process using components. I quickly covered. I wanted more time, but of course we have gone beyond our
Yeah.
time. But how we saw how we can create components by defining the outputs, defining the parameters, and putting an icon. Right. We will look into this more on Friday when we look into the reuse of models. We will try to play around more on that day. But we saw that process. We also saw how we can use the fixed delay, to time various processes, right? So we can match with when event occurs, this process should start, and everything should not start at 0 seconds, right? And then
Right.
just to summarize, like when you see a data, uh, verify the data before drawing any conclusions. Like when you see the data, we should not just say that this is impossible. Like we should try to see like what might be the thing that is triggering that behavior, right? And then uh, if possible, try to create very simple model and try to justify or try to answer that behavior, and try to see if you can justify the patterns in the data. For instance, yesterday we saw the carbon dioxide emission pattern, right? We had a very simple model, a qualitative model, but we were able to understand what are the dynamics involved, right? So next time when you see a similar chart, oh, maybe this is because you have a combination of two different processes which have different dynamics involved. And that's why the cumulative effect is something like this, right? So the
Right.
idea is to look into data, try to model it, and um, try to validate it. Right. Okay, Vedat, is there any final question? Else we should wrap up. We are way
Right,
beyond our.
right, right. We have question from Francisco. He is asking whether the trick, the percentage trick for the name is manual, isn't it? Yes, it is. It is manual as far as I know. Right, Ankit?
Yes, for this case it is manual. There are instances where uh, you can use percentage as well, but in today's model we used it manual. Yap has a question. He's getting some errors in step 2. So what I will do, Yap, I will maybe tomorrow I will load the, I will in the download materials I will provide the updated modeling principles.mo file that you can um, take, that you can check and verify. And
Right. Also, what about the recording of today? Will be available today,
I think
this class?
Cassidy would like to make it available today. Let's see if
Okay.
everything goes all right. Then yes.
Yes,
Uh,
recording should be available later today.
Yes. Yep. We have been in conversation before. If you can send me the error messages that you are getting, or if you want to post it in the community, just post the error messages. And looking at the error messages, I can try to suggest what might go wrong, right? If you don't want to wait until tomorrow. Yeah. Okay. Thank you, everyone. Thank you for today. And sorry we got a bit delayed, but it was too
Mm,
much to cover. Thank
yeah,
you.
I guess it is our norm, Ankit. It
Yeah.
doesn't matter.
I thought 90 minutes was
Yeah,
too much. Okay. Anyways. Yeah. Thank you.
yeah, yeah.
Bye.